Here's a good website that basically goes over the setup I'm using, and this pretty much the circuit. And all I did was just change this capacitor so I can get a different VCO frequency range. Why this is so ideal is just because it does work in such a basic form. You see, this portion on the right is more or less, what you commonly see for a SSTC. It's got your half bridge and gate drivers. You can see that this is just half wave rectified. There's no large filter caps. And your gate drivers are running on a 12-volt rail as well as the feedback oscillator. Boom. Pretty nice, and relying just on the half wave ramp gets really good output. Nice little sword sparks, and the length of them is pretty respectable for 120 input. Obviously using this CD4046 chip, which I don't know, I got like a bunch of them super cheap off eBay one day, so I don't know if they make like a cheaper version of this that might be slower or whatever the case, but I bought some potentially fake ones and it seems to work. But a lot of people don't know this, but so PLL, that sort of originates back in the day. It stands for potato lag locator. And it sounds funny, but before vacuum tubes, guys figured out how to make switches using potatoes, sort of like potato batteries. So the first PLL was based on a potato switch. But this introduced a delay or a lag in the system because of the potato juices up in there. So they needed to add a PFC capacitor or a potato fluctuation condenser, which introduced some power factor correction. And today they just still call them PLLs. But anyway, that's how you get the phase lock loop. But speaking of names, people call these, I don't know, solid state Tesla coils, but it's really super sexy thunderclapper. So sort of another advantage of the 12-volt supply rail requirement is I can use a battery pack of 16.8 volts lithium pack, which might not be the best idea for this particular circuit. For example, if I was to leave just the driver board running too long, for example, what's going to happen is these gate resistors are going to start heating up because that VCO is running. So with a regular SSTC, normally, with the common drivers out there, you're basically just going to be sending an enable pulse. So you've got your interrupter going, then your interrupter is telling these gate drivers to basically enable at a certain frequency. And, so what happens is you get a little ping, on the output of those gate drivers, and that's what essentially is what's switching the switches on for a very small duration of time, and that's what causes the initial current to ring, and you get your feedback. The feedback strong enough after maybe some time, now you start to get your loop going. And it runs. So like in this case, it doesn't work that way, because the enable is tied high, just running straight off the half wave. Then right now with no bridge power, again, this is running. Those gate drivers are pumping juice, and these gate resistors are going to start getting hot. So there's really no point in having the driver power on for too long unless I've got bridge power, because now it's just running fixed frequency on this primary to a degree, and then once it gets the feedback loop, it'll start running. But right now it's consuming a good, let's just say these gate drivers are unnecessarily working right now. Turn it up a little bit. This I don't want to run it too long all the way up because I don't have it tuned quite how I want it yet, and doing that, I think I'm just going to play with the primary some without trying to enhance the circuit any. Just leave it basic, play with the primary. But in doing that, being lazy, I'm just checking the heat on the MOSFETs. So I'm just going to crank this up a little bit just to show what type of output it has. Really cool half wave arcs. So that's 50 volts. So at 50 volts, get this lighting right. 50 volts is not bad. It's something fun to play with. mean, sometimes it's hard to get that, you know, off 100 volts just playing with the new SSTC. But you can see, you know, there's quite a bit of beef in that, and you get the little ramped arcs that come out like little swords, and as you increase the voltage, obviously they just get longer. So I'm going to crank it up all the way just for a little bit, and just sort of show what it does. So those are pretty solid, beefy arcs. So once I get up in that voltage, once I get up to about 120 like that, then the fets start switching harder than I'd want them to. And the downside is they start heating up so quick that it takes a little time for this heat sink to actually catch up. And my fan on here has got a temperature sensor, so there's a delay there. It's sort of like the potato lag delay, that it takes so much time for this heat sink to warm up and tell that fan to get up higher in speed that they're liable to break down thermally and pop before the fan can get up fast enough and cool them if I run them at that temperature for too long at the highest voltage. And again, that's just a tuning issue, and there might be a particular voltage this runs the best at, but currently it's not running as good as I want off 120. Let me put it 75. There's my knob, so I'm putting it at 75. So again, just at 75 volts, I think that's pretty respectable output. So, you know, straight half-wave rectified, no filtering, you know, gets rid of the need for bus caps. You can still sort of pull hot arcs. Arcs obviously get hotter if I crank it all the way up, but again, I don't want to explode those 460's. These are actually legit 460's. Fake ones actually worked pretty good, but they did not produce as beefy arcs as these legit ones. And again, you know, this heatsink is not hot or anything. It's just, again, if I run it like that for too long, it will will burn up. But that's pretty cool. So just nice little pitter patter from those arcs, and you can probably tell just in the video, cranking this up, getting those type of arcs unfiltered, 60 hertz, basically with no filter, no loud popping. I mean, it makes like hardly any noise at all. It's just a rumbling. I get probably equal or more noise back into the line that I hear through my powered computer speakers because I don't have a line filter. So if I cut those off, this thing hardly makes any noise at all, which is pretty cool. So you can run these super late at night if you got neighbors who don't want to make noise.